Hello everyone, so here we have problem number 5 from kinematic or projectile motion. So the given values are here. So basically you have to find position of the particle after explosion in a x final position. If needed, you can also find y final position. So basically you have, suppose that you have the object was launched at certain initial velocity and at an angle of theta 57, and after some time, let's say time is equal to 46 seconds, let's say suppose it's here and it's exploded, so you have to find what will be the x final position at this point, and also you can find y final position at that time. Okay, so to use that one, first of all you have to resolve this initial velocity into two components. One will be basic one will be your x vx initial and then vy initial components. So that is defined by the formula, which is vx initial is equal to v initial time cosine theta, and vy initial is equal to the v initial sine theta. So you have to calculate that one. After that you have equation way to find x final position, which is x final position is defined by the x initial plus vx initial time plus ax times squared over 2. Since we know that acceleration in x direction is always equal to 0, therefore we can cancel this part. This part can be removed because acceleration ax is equal to 0. And also we know that the projectile started from initial position, which is x initial is equal to 0, y initial is equal to 0. So therefore this will be also 0. So you end up with x final, which is vx initial, and we also know that vx initial is equal to the v initial cosine theta times time. So by plugging those given values, you will get the x final position at a time of 46 seconds. Now what about y final position? Now in this case you have this equation where y final is equal to the y initial plus vy initial time plus ay times squared over 2. Since we know that ay is equal to the negative of the g, because g is always pointing downwards, okay? So therefore we're putting negative g, which is equal to also minus 9.8. So by saying that y initial is equal to 0, and we end up with this equation, which is this one, vy initial time minus gt squared over 2. Okay, so vy initial itself will be equal to the v initial sine theta. So by plugging those numbers, you will get the final y position at a time of 46 seconds.